Hello, welcome to my class. Today we're going to explore function. So what is a function? So by the definition, function is a rule for relationship between an input and an output. So sometimes we will say input is the dependent variable and output is sometimes we say input is the independent variable and output is the dependent variable. Okay, so, but this is not done by the definition of function, a rule between these two functions. Also, in bridge, each input value uniquely determine one output value. And then we will say the output is a function of an input. The output is a function of our input. Okay, let's say some human language. This is mathematics, not human language. Such as, here's the example. Now you've seen a menu from a Starbucks. So what will be the input? The input is you're trying to order some coffee, such as mocha, and then you tell the cashier, I want a grande mocha, and then they will charge you $2.95. And then if you tell them, hey, I want a caramel espresso, a venti one, they will charge you $3.20. So here is the function, the name of the item, including the size, and then the output would be the price. So we will say the price is a function of the item. But you can do something like, hey, the opposite. I given you the price and you tell me the item. Because if I tell you that, hey, I want something that $2.19, then you wouldn't know, hey, am I trying to order a grande Java chip or a grande caramel espresso, right? So you need to be careful which one is the input, which one will be the output. Another really, the example that we've seen all the time is our grading scale, right? So if you are above, if you're above 60%, you will earn a D. If you're above, which is 70% to 79%, you will earn a C. So this is 69%. If you are 80% to 89%, you will earn a B. If you are 19% to 100%, you will earn a A. Otherwise, you will get an F. Okay, so how does this work? So a function is, I give you a number. For example, right now you are 62%. That means your output is going to be a B. So this is a function. All right. So another way is, let's consider this bank information. Is your balance a function of your bank account number, or is your bank account number is a function of your balance? So now you need to think about that, consider that, take a pause to think about that. So when you think about that, if you tell the teller at the bank that, hey, I have 3,000 left, could you please give me my bank account number? Can they do that for you? No, right? But if the opposite, you tell them that, hey, here's my account number 123466620, and then the teller will tell you that, hey, your balance remain 2,000, right? So which one is the input? The input should be our account number, and the output should be your balance. So that means this is the right statement. Your balance is a function of your bank account. Okay, so now the last is the notation of a function. All right, so the notation of a function, we will write it as the output equals to the function of input. That means we read it, the output is a function of input, like what we did earlier, how we defining a function. The output is a function of input. So we've seen this a lot. So usually what will be the output? Y, we use Y as an output, right? So I would say Y is a function of X. X, our early example, our balance is a function of our account number, right? And the earlier function is like the price is a function of the item that we order. Okay. So this is one way to express a function. Another way to express a function would be a table. How do we use a table as a function? Let me use the same example. So the number of days in a month is a function of the name of the month. So remember this example. The number of days in a month is a function of the name of the month. So here we go. So if we use the notation that we have earlier, if I give you the, hey, function of November, so what would be the output? So how many days in November? 31 days, right? Let me check. Hey? 13 days, I'm sorry. 13 days. So if we put January, so the output would be what? 31 days. If we put February, in general, it will be 28 days. So how can we write it as a table? So for the table, usually our first row, first column, we will have our input, which in our case would be the month, the name of the month, right? Such as we don't have to use English, we don't have to use letters. We can also use numbers such as 1, 2, 3, 4, to 11 and 12. We totally have 12 months. And then what will be our output? Output usually is the second column, which is the number of days. For example, in January, we have 31 days, 28 days, and 31 days, 40 days. When it comes to November, we have 13 days. December, we have 31 days. So here is a function. Sometimes they will write it in a column, such as they give you an input and output. So input could be 2, 5, 8, and then the output would be 1, 3, 6. What's that mean? That means f of 2 equals to 1. F of 5 equals to 3. Another one would be here. Okay, so now let's look at all these three labels. Remember our definition of function. Each input is uniquely determines one output. The key word is uniquely. Earlier we did that here. So now tell me, in these three graphs, in these three tables, which one is function, which one are not function? Well, let's take a look. So for the first table, one input determines one output. This input determines one output. F8, if you put in F8, you know it's equal to 2. Similarly, for this one, if you put in F-3, it's equal to 5. F0 equals to 1. F of 4, though, also equals to 5, which is okay, right? Because these input determine one output. Now let's take a look at the third table. We have f of 1 equals to 0, f of 5 equals to 2. However, what about the last one? The last one you also got what? F of 5 equals to 4. That means this input is not uniquely determine one output, which means this is not a function. So a similar idea is like, hey, when you order coffee at Starbucks, if I just want a tall of mocha, and then one cashier tell you that, hey, this is $2.70, and then the other teller tell you that, hey, this is $3. That will confuse you, right? It's okay that two items, they are the same price, but it's not okay that one item, they have two different price. So that is function. All right, after we tell you what is a function, now the next step is how do we solve or evaluate a function? Okay, so if I give you a graph, such as your input is n, your output is q of n. It's not necessary always x and y f of q. They could use different letters. But first of all, this is a function. Secondly, how do we evaluate or solve the function? If I ask you evaluate means I given you the input. You need to find me the output. Solve a function is the opposite. Solve the function is you will be given an output and you're trying to find out the input. Okay, let's do the evaluate first. So by this graph, if I give you, hey, evaluate f of 1. no, I'm sorry, not f. This is a function of q. So it should be q of 1. So q of 1 is when n equals to 1, q equals to what? So now look at here. When n equals to 1, q equals to 8. So q of 1 equals to 8. What about q of 3? Q of 3 equals to, well, when n equals to 3, q equals to 7. So q of 3 equals to 7. So similarly, q of 4 is equal to, when n equals to 4, q equals to 6. Okay, now it's solved. Now it's like I don't know n. Well, but however, I know that the output equals to 7. Then now we're looking for output. So when the output equals to 7, n equals to 3. So we solve the function equals to 3. And then another example would be if I tell you that, hey, q of 4, oh, sorry, q of n, q of n equals to 6. Well, now we might have two answers, right? Because when the output equals to 6, n could equal to 2, or n also equals to 4, which is okay. So we will have two answers, n equals to 2 or n equals to 4. So this is solving the problem. Okay, in next class, we will talk more about functions. See you next time.